Hello and welcome to our project 8BitPool, which is inspired by the classic 8 ball pool game. Our objective for this project was not only to create a game that people would be familiar with, but also to design a game that could be a good challenge to implement with the limitations posed by FPGA. We initiated our work by setting up the display and implementing Q rotation through the joystick. Moving forward, we tackled the task of restricting the ball to the boundaries of the game board.
After that, we had to make this an actual game by taking in user input in order to control the ball's movement. Now we implemented a system that is able to read how long a button was being held and shoot the ball in the direction of the cue. At this point, we also implemented the deceleration for the ball.
After this came the time to implement multiple balls into our game. This involved us spending a lot of time trying to figure out how the balls would collide, which eventually after some testing and a lot of theory crafting, we decided would be elastic collisions. This meant that on every ball collision, the ball velocities would be exchanged. However, implementing even such a simple system on the FPGA proved to be quite a challenge. Eventually, after a lot of trouble, we were able to implement a collision system that was quite fun to play with and also was pretty consistent.
At this point, our game was starting to take good shape, and now all that was left was implementing the scoring system and some state transitions. We envisioned three main states for our game: the start state, the game state, and the end state. The player would initially load into the start state, and they could return to this state at any point of the game by simply flipping the reset switch. From here, the user could also move to the game state by pressing the button to start. When inside the game state, the player could use the joystick and the button controls to take shots and score some points. And then depending on whether they reach the win or lose condition, they would be sent to the appropriate end screen, the win screen or the lose screen. And from the end screen, the user could go back to the game screen by just pressing the start button again. Our main output, which was our VGA display, is purely dependent on the state of the game, which is why we believe the logic of our game is that of a Moore machine. Once the state transitions were implemented and the scoring system was finalized, we had successfully completed our 8-bit pool game on the FPGA Basis 3 board.